Hi everyone, in this video I'm going to show you how to create this spring plunger and create the animation you see in front of you. The first component I'm going to create is going to be the spring plunger housing. I'm going to create a new part and I'm going to click on the front plane and create a new sketch on this plane. Now I'm only creating sketch of half of the spring plunger housing because after that I'll be using a revolve feature to revolve this sketch around its axis. This line is going to be 3 millimeters, which is essentially a radius of our spring plunger. The length is going to be 15 millimeters. Now the plunger is going to have a hole inside, which is going to have a radius of 1.5 millimeters. And this dimension is going to be 5 millimeters. Exit the sketch. I'm now going to click on sketch 1, go into features, and click on revolved boss/base. For the axis of revolution, I'm going to click on this line and right click to confirm. I'm going to rotate this and create a new sketch on this face. I'm going to choose polygon, point in the middle, click here, and I'm going to dimension this to be 3 millimeters between these two lines. Now to fully constrain my sketch, I'm going to constrain one of these lines to be horizontal. I'm now going to use extruded cut, and for the depth, I'm going to choose 2.5 millimeters and click OK. I'm now going to click on chamfer, and I'm going to click on the bottom edge. Now in here, I'm going to click on this selection right here, which says distance and distance. I want to choose asymmetric, and the first dimension is going to be 1.5 millimeters. Hit enter, and the second one is going to be 0.5 millimeters. And confirm. Now I'm going to add another chamfer, but this time I want the first selection, angle and distance. So for the distance, I'm choosing 1.2 millimeters, an angle of 55 degrees, but items to chamfer this edge right here. Confirm, and chamfer is done. I'm now going to create a thread. This spring plunger is essentially an M6 spring plunger. So I'm gonna go ahead into Insert, Features, Thread. Now to start the thread, I'm going to click on this edge and up to selection for the end condition, I'm going to click on this edge. In the specification, make sure it says metric die and the size M6 by 1. And we are going to cut the thread. Confirm. Now, as you can see, just by creating this thread doesn't really look that great. As you can see, it promptly ends in one place and doesn't really look too realistic. So what I'm going to do is go into thread, go into edit feature, and for the thread location, I'm going to click on offset. And let's choose 2 millimeters, but make sure that the 2 millimeters are actually away from the part. So click on these arrows, and then on the other one as well, offset. And we can see that the offset is going away from the part. Confirm. And as you can see, this is looking much better. If we zoom in, as you can see, there is still a little bit left here. So if we want to, we can go into thread 1, edit feature, and we can even put down 3 millimeters and click OK. Perfect. Now I'm going to choose material as plain carbon steel, and I'm going to click on this arrow, and in here change the appearance. So I want to change the appearance of the entire part, So in here, I'm just going to choose something a bit darker and confirm. Okay, we can save this component. I'm going to name it housing. Save. Now the second component I'm going to create is going to be the spring. Again, create a new part. I'm going to click on the front plane and create a new sketch. Now in this sketch, all I'm going to do is I'm going to create one line, which is going to be 8 millimeters long. Exit the sketch of workbench. Now again, click on the front plane and now create another sketch, and I'm going to create a circle. This circle is going to have a diameter of 0.5 millimeters and distance from the origin is going to be 1.25 millimeters. To fully constrain my sketch, I'm going to say that this profile needs to be in line with the origin. I'm now going to click onto features, going to swept boss/base, and for the profile, I'm going to click on this little circle, and for the guide curve, I'm going to click on this curve. Now I'm gonna go down into options, and in profile orientation, keep it to follow path, and profile twist, choose specify twist value. Twist control, I want to do revolutions, and I want to do 7 revolutions. Hit enter, and as you can see, this creates our spring. Confirm. And now I'm gonna go ahead and click on the front plane and create a new sketch. And I'm going to trim it at the bottom, so we have some flats at the bottom and at the top. So what I'm gonna do is I'm going to create one rectangle from the origin. I'm just going to dimension this. It can be any value you want, just make sure that everything from the spring in here is included in the rectangle. So let's say 5 millimeters. And I want to make sure that this is coincident with the origin. Perfect. And I'm going to do the same thing on the other side. And because I don't have any origin here to snap my rectangle to, I'm going to create a point. And this point is going to be concentric to this circle. So I'm going to say that there is going to be a relation, concentricity. And then this line is going to be coincident to the point. Okay. And again, you can put any value, let's say 5 millimeters. Exit the sketch. And I'm going into features, extrude cut, direction 1 through all, enable direction 2, and also through all. And as you can see, this now creates flats. Okay. Now, another thing I'm going to do is enter the sketch of workbench on the front plane again, and I'm just going to create one line, which will just serve as an axis for my spring. I'm going to click on this arrow again and change the appearance. And I'm going to say I want red color. And I'm just going to change the material to plain carbon steel again. And I need to change the color again because the material overrides the appearance. Okay. I'm going to go ahead and click Save. Spring. Now the third component is going to be spacer. So again, create a new part, sketch, new sketch on the top plane, and just create a circle which is going to have a diameter of 3 millimeters. Exit the sketch, and I'm extruding this by 1/2 of a millimeter. Again, for the material, I'm choosing plain carbon steel. And for the appearance, I want this spacer to be quite visible. So I'm gonna choose yellow color and click Save. And the last component I'm going to make is going to be the ball. Click on New, Part, go into Front Plane and create a new sketch. I'm going to create a circle. And then I'm going to create a line in here. The circle is going to have a diameter of 3 millimeters. And I'm going to trim everything on one side, so I only get 1/2 of the circle. Click OK and exit the sketch. I'm going to click on the sketch, go into Features, and use Revolved Boss/Base. And for the axis of revolution, this line right here. And this is our ball. I'm going to specify the material as plain carbon steel. And for the appearance, I'm going to choose white color. Save. I'm now ready to create assembly out of all of these components. So click on New, Assembly, click OK. And the first component I'm going to insert is going to be housing. Place the housing in. We can see that the housing is our first component and it is fixed. Now I'm going to click on Insert Components and insert the spring. Now if you don't see this line that we created, the sketch, click on this little eye, click on this little arrow next to the eye, and make sure that Sketch View Sketches is enabled. I'm going to click on Mate, and I'm going to click on this axis and on this inner cylinder, and I want them to be concentric. I'm now going to bring this up, and I'm going to click on this flat at the bottom, and the bottom of the hole, and I want these two to be coincident. Okay. Now I'm going to insert another component, which is going to be the spacer. Click Open. Now I'm going to click on the outside of the spacer, and then in here, and make sure they are concentric. Now this spacer, I want it to touch the spring, and click OK. All right, I'm going to go into Insert Components and add the ball in here. Now, as you can see, I didn't create any sketch that I can mate to the center of the spring plunger, so I can't really mate it to be concentric to the spring plunger. So what I'm gonna do is click here, open this part in New Window, go into Front Plane, and create a new sketch now. And I'm just going to create one line, which is basically going to serve as an axis for this ball. Close this, save the changes, rebuild. I'm now going to click on Mate, click on the line, click here, and make it concentric to the spring plunger housing. And I want the ball to always touch the spacer. So make them tangent. Perfect. Now our spring plunger assembly is complete. I'm now going to show you how to create a simple animation of this spring plunger. The first thing I'm going to do is to create a cross section so we can see what's going on inside of the plunger. I'm going to click on the section view, and I'm creating my section view on the front plane. Click OK. Now the second thing I'm gonna do is to have a look at the spring. So in the specification tree on the left, I'm going to click on the spring and then click on Edit Component. Now bear in mind, if you want to edit component from within the assembly, you first have to save the assembly. I did this off screen, so if you haven't done so, do it now. Okay, if you remember, we defined the height of the spring to be 8 millimeters by this simple sketch in here, which is essentially just a line 8 millimeters long. Well, what I'm gonna do now is grab this dimension and delete it. The height of my spring is not constrained at the moment. You can see that the blue point in here signifies it is not constrained. I'm gonna go ahead and click on the point and click on the bottom surface of the spacer and add a new relation, coincident. Click OK. Now, what I have essentially done now is I'm driving the height by the position of the bottom face of the spacer. So the spring is going to be as high as the position of the bottom face of that spacer is. I'm going to exit the sketch. Now, I'm going to go back into the assembly mode. And before I can actually demonstrate what I've just done, I'm gonna go into mates for the spring and have a look at the third mate, which is the coincident between the bottom face of the spacer and top of the spring. Now we need to delete this mate. You might be asking why. Well, the reason for it is we have now changed the height of the spring to be driven by the position of the bottom face of the spacer, right? So essentially the bottom face of the spacer is always going to touch the top of the spring, regardless of this mate. This was important during the assembly, but now because we changed the way that the height works, height is driven by the position of the spacer, we can remove this mate. And in a way we have to, because in this particular instance, it is sort of over-constraining the assembly. Okay, so now if I move the ball together with the spacer, right, the position of the spacer changes. So if I rebuild the assembly, there you go, the spring changes. You can see visually it is compressed, and it is compressed because the height is now different. Okay. Now, the next thing I'm going to do is actually limit the range of motion of this ball. Because in reality, you can imagine the ball cannot end up outside of the plunger, and on the contrary, the ball cannot end up too deep inside of the plunger. So what I'm going to do is click on the mate and click on this point, which is the middle point of the ball, and then this surface right here, the top surface of the housing. Go into mates, go into advanced mates, and go into distance. Now this becomes a little tricky, sometimes with the direction of the distance. But the first thing you want to do is make sure you start with the ball inside of the plunger. So as you can see, it is now 1.14 millimeters outside. I'm gonna flip dimension, and it is now 1.14 millimeters from this surface inside. That's good. So we want the maximum distance allowable to be 1.5 millimeters, which is the radius of the ball. But again, we're gonna flip dimension here. And then the minimum distance is 0 millimeters. Click OK. And now you can see that I can grab the ball, and this is as far as it goes. It doesn't go any further. And this is as deep as it goes. Great. So this is set. Okay, I can go ahead and click OK here. I'm going to rebuild the assembly. Great. And now we can go ahead and create the animation. So the way in which you do the animation is via the motion study in here at the bottom. Now, if you don't see this motion study tab, you can go ahead and right click anywhere in here. It even works if you right click on any of the icons, and make sure that in this list, the motion manager is enabled. You see, if I disable it, it's gone. Okay, I'm gonna bring the ball up as far as it can go. And I'm gonna go ahead and click on Motion Study 1. Now in here, we've got a bunch of new icons and new stuff. But the first important thing we want to have a look at is this button in here. Make sure it is switched to animation and not basic motion. Okay. Actually, before we do the animation, we don't really want to see these sketches. So I'm gonna click on this arrow and just turn them off. Perfect. So now this state with the ball sort of at the top, right? I can bring it to the top. Whatever we do now is going to be the state at 0 seconds. So we are basically starting at 0 seconds with the ball all the way up. Well, now let's say that after 2 seconds, I want the ball to be all the way down. So the first thing I'm going to do is click in here 2 seconds, and I'm going to bring the ball down, as far down as it goes. And as you can see, this created motion. So now if I want to see the animation, what I have to do is to click on this little button that says calculate. Click on it, and it is going to take a couple of seconds to calculate the animation, but you can already see that there is a motion on the screen. As you can see, the ball goes down. At the moment, my animation is playing in loops. You can go ahead and stop it if that is the case for you as well. If not, it might be because in this button in here, playback mode, mine is set to loop, and yours might be set to normal or reciprocate. Okay, so now after 2 seconds, our ball is all the way down. Let's say that after 4 seconds, I want the ball to go up again. So what I'm going to do is click on 4 seconds and bring the ball up as far as it goes. As you can see, new motion was created, but our calculation is only done up to here, up to 2 seconds. So we have to recalculate. So again, we are starting from the top. After 2 seconds, we're going to be at the bottom. And then again, we're going to go to the top. Great. Again, I'm going to stop the animation because it's playing in loops. And there you go. This is the animation of the spring plunger. Now, if you want to export this as a video and a smoother animation, a smoother video, you can go ahead and click on this icon right here, Save Animation. We can name it Spring Plunger Tutorial Animation. I'm going to keep everything default except for the frames per second, which are going to be 30. And I can go ahead and save it. For the compressor, you can keep it default and click OK. And in here, just click Yes. Now, depending on your computer, this might take a couple of seconds or minutes, but as this is not a big animation, it should be done fairly quickly. Now you can go ahead and open the video, and as you can see, this is our animation. Thank you very much for watching this video. I hope it was useful, and let me know in the comments if you've got any questions. I'll be more than happy to help. Thank you.